This is Donald. If you had to ask him where he thinks a woman belongs, he'd probably say here. This is Andrew. And if you had to ask him where he thinks a man belongs, he'd probably say here. The thing is, though, if you're honest with yourself, your own thoughts probably aren't too far off. There's a reason why something as cool as this and as funny as this would make your head turn. Without realizing it, most of us make our choices based on nothing but a stereotype. You're not alone. This is a deeply ingrained cognitive bias that society has conditioned into us. I'm Tammy. I'm a grad in Cape Town doing the BA program, and I also have an interest in machine learning and data science, and that's why I chose this topic. So over the last few decades, AI and machine learning have become central to decision-making in every industry, from healthcare to finance and even hiring. Models are being developed to automate decisions, and they're trained on massive amounts of real-world data. But what happens when that data reflects the inequalities and biases already present in the world? The reality is that models mimic the world they're trained on. And if that world is biased, if it's unfair, then so will the models. While efforts to reduce bias in AI are well-intentioned, they often create models that don't accurately represent the complexities of real life. So what's the real goal here? Creating fairness in a world where fairness doesn't really exist. That's what we are exploring today. Humans make decisions based on bias every day, whether they admit it or not. When we think of bias, it's often negative, but from a cognitive science perspective, bias is a shortcut. It's a tool our brains use to make fast decisions in a complex world. For example, when you make a snap judgment about someone's trustworthiness based on their appearance, you're using bias. Your brain is essentially running a statistical model based on past experiences, trying to predict an outcome quickly and efficiently. In many cases, it works well, but as we know, it can also lead to faulty conclusions, just like AI. This is exactly how machine learning models operate. They use patterns from historical data to make predictions. The problem arises when those patterns are rooted in inequality or prejudice. Just as our brains are biased by the world we've experienced, machine learning models are biased by the data they are fed. Let's talk about Amazon, one of the largest tech giants in the world. As a heavy user of machine learning, they implemented an AI system to automate their hiring process. It sounds great, but in 2015, they discovered a significant issue. The algorithm was biased against women. Why? The model had been trained on resumes submitted over the past 10 years, where most of the applicants were men. Naturally, the model learned to favor men for technical jobs. After all, if the data shows men applying more for these roles, why wouldn't the algorithm conclude that men are the preferred candidates for tech jobs? The logic here is simple but flawed. To say something controversial, men are preferred for tech jobs. That's what the model learned, because for years, that's what the data reflected. But we know that this isn't the world we want to build, even if it's the world we live in now. The result of this was that Amazon scrapped the project because it was impossible to correct this deeply embedded bias. So what do we do when our models reflect this kind of bias? The tech community has developed two main strategies for mitigating bias in machine learning: pre-processing and in-processing. Pre-processing. This is where we clean up the data before training, trying to fix the bias at the source. In other words, we're telling the model, hey, ignore that this data is biased, just focus on the fair parts. In-processing is where we embed fairness constraints directly into the model's training process. We make the algorithm care about fairness, even if the data it's being trained on doesn't. Both sound great in theory, but in practice, they create models that don't really reflect the real world. By trying to fix bias, we're essentially creating a false version of reality. The model might become fair, but it's also less accurate. Imagine teaching a medical diagnostic AI to ignore racial disparities in healthcare data because you want to create a fairer model. That sounds noble, but in doing so, we might overlook the very real fact that certain diseases affect different populations in different ways. This leads to the next big question. How do we measure fairness in machine learning? In a world as unequal as ours, it's nearly impossible to define what fairness even looks like. For example, if you design a model to be fair to one group, you might unintentionally make it unfair to another. There are various metrics for fairness in machine learning, like equal opportunity and demographic parity, but none of them offer a one-size-fits-all solution. Different fairness metrics give you different results. What's fair according to one metric might be entirely unfair according to another. That's why we face such difficulty in creating AI models that are truly fair. For instance, in recruitment, a model trained to achieve demographic parity might select equal numbers of men and women for tech jobs, but if the underlying qualifications and experience distributions are unequal, the model could end up making suboptimal hiring decisions. Plus, mitigating bias often comes with computational trade-offs. Fine-tuning models with fairness objectives can reduce their overall performance in other areas. For instance, for optimizing for fairness, models may lose the ability to generalize effectively in new environments. This isn't just a theoretical issue, it's a real-world limitation in how we develop and deploy AI systems. A little while ago, Derek did his tech talk where he spoke about the ethical challenges AI poses, especially in the context of hiring and recruitment. He shared several real-world cases where AI systems, despite their potential, have failed due to biases deeply ingrained in the data they were trained on. For example, he pointed out the iTutor case, where AI-driven recruitment led to discrimination against women over 55 and men over 60. Amazon's model is just another example in a long list of AI systems that, despite good intentions, ended up perpetuating the same inequalities they were designed to eliminate. These insights underline how AI systems can amplify existing inequalities when ethical oversight is missing. So here's the bottom line. Machine learning models reflect the world they are trained on. If the world is unequal, the models will be too. We can try to rebalance the scales, but doing so creates a version of reality that doesn't exist. How do we measure fairness in a world that is inherently unfair? At the end of the day, the real challenge isn't just about fixing the bias in AI. It's about addressing the inequalities that exist in the world that AI reflects. Until we do that, our models will remain imperfect mirrors of a biased reality. Thank you.